Alrighty, so um, we've been working with antiderivatives. So far this semester, we've been working with antiderivatives. Antiderivatives is the most common way to do that first bold word up there, integration. Okay, integration. So um, integration is what we're going to focus on this semester. But we've been integrating before, right? Anytime you're solving anything with with this guy here, right? That symbol there, that means integrate. Now, the most common way to integrate is antiderivatives, finding antiderivatives. That's why we've been working with antiderivatives, okay? But we're going to kind of pause on antiderivatives for a second. We're going to go back and to see what is integration. Why do we integrate? What are we doing when we're integrating? Okay? So very simply, integration is the process of finding the area underneath a curve or a function. Okay? So you guys are used to seeing functions, right? Graphing functions, right? We're going to see quite a bit today, but I'll give you an example of one. So like if you have a parabola, all right? What we're going to do is they're going to give you what's called bounds. Bounds. Starting point and ending point. So let's say the starting point is 0 and the ending point is 4. What that's going to do is it's going to create a region underneath the curve. And what integration is how much area is there, right? You guys have been doing area since, elementary school, right? Area of squares, area of rectangles, area of triangles, area stuff like that. You guys have done area, right? The problem is, if we're finding area of that, it's a curve, right? So it's a little bit more difficult, okay? But that's essentially what it is, okay? That's essentially when we integrate, that's what it's helping us do, right? Just like finding the derivative was helping us, or sorry, finding the derivative was helping us find the slope, right, at a certain point. Integration is helping us find area under the curve. Okay, area under the curve. That's what it's for. That's its purpose. Okay. The most common way of doing it, of finding area under the curve, is antiderivatives. We'll come back to that, but I just want to show you what's called Riemann sums. Riemann sums are another way of doing it. Okay. So one method we're going to talk about today is, it's called Riemann sums, but it's also called rectangular or trapezoid approximation method. That's another name for Riemann sums. It's all the same. Okay. So let's start with some easy ones. Okay. This is not really a curve. You see the blue line. It's not blue on your paper, but you see the blue, right? Let me shade it. So what I want you to do is find the area enclosed by the graph. So your bounds are 0 to 8, right? So what I want you to do right now is find the area bounded by the graph. So find the area for each. The area that I'm highlighting. Okay? Find that area to your best approximation and write it there. I'll give you a few minutes. Okay, so the first one. What area did you guys get? You probably got the same area. What area was it? What area, what was the value that you guys got? Anybody care to share what they got for the first one? What's the first area? So the left, one on the left. 22? Okay, thank you. So 22. So Danya, how did you do that? What was your method for figuring out that area? Count to the squares, right? Area is length times width, right? And so each of the squares, so these little squares here, talking about like little squares like that. Yep. Okay. So each of those squares is a 1 by 1. So each of those squares is 1 unit, right? 1 unit squared. And then there's 22. How many people did it that way? Anyone else do it a little different? Anyone else do it differently? Anyone else do it like this? And say, that's 4, that's 6, that's 2, and this right here is 2 by 1, 2, 3, 4, 5, 10, and add them together. Anyone do it like that? Yeah, rectangles. Okay. All right. How about the second one? So the second one, if we do the same way, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, and 26. Same way, right? Okay. So what you did on those first two was integrate. You integrated from 0 to 8, right? So what you guys did was this. You integrated from 0 to 8 for the function. Hey, come on. Notes are right on your desk right there. I'll take that, yeah. Thank you. Okay. That's what you guys did right there. Your bounds were 0 to 8. Right, we started at 0 on the x. When it talks about bounds, we're talking about x. Okay. And what did you find the area under the curve of? F of x. And then remember the dx always comes at the end. That's what you guys did for each, right? So for the first one was 22, for the last one was 26. Okay. All right, so now let's look at these guys here. What I want you to do is, so the area under the curve, still from 0 to 8, right? Still from 0 to 8. So the bounds are still the same. So that's the bounds there. We call them bounds, the beginning and the end of the area. Right? Now what I want you to do is do the same thing. Do the same thing. Find the area under each of those functions, f of x. Now notice it says approximate, right? Because you're not going to get exactly the right number. Approximate it. Come as close as you can to what the area under the curve is for each. Okay, I'll give you a few minutes. All right. You make, so when you're doing this process, you make squares or rectangles, right? Right. You can do a square and a rectangle. Like I can do a rectangle here. Is that pretty much what you did? You made 2 squares here, 2 squares here, and then like I said, the approximation. So the boxes that had only went through like half, right? You kind of approximated. That's kind of what we're doing today, right? Rectangular approximation method, Riemann sums. That's kind of what we're doing today, right? So this is kind of a little explanation on what Riemann sums or rectangular approximation method is. Okay. Suppose we wanted to know the area of the region bounded by a curve, so the gray area. The lines bounded by a curve, the curve is blue on mine. It's not on yours, but it's on mine. The x-axis, that's the lower bound, and the 2 bounds, A and B. Right? Suppose we wanted to find that area in there, shaded gray, this area here. Our first step is we're going to divide the interval into subintervals. We can then draw rectangles using the width of each subinterval as the base. The height of each rectangle is determined by the function value at the point in the specific interval and can be determined using 3 different methods. So there's 3 different types of rectangular approximation. The first one is called LRAM. The RAM part is rectangular approximation method. L is left. L uses the left endpoint. R uses the right endpoint, and M uses the midpoint. Okay? We're going to do a couple examples. So this is kind of the explanation of what we're going to do. Pretty much what you're going to take out of this is we're going to make rectangles to approximate the area under the curve. Okay? We're going to make rectangles, just kind of like you probably just did, right? So look at example number 1. That's kind of like what we're doing here. So look at example number 1. That's an example of left RAM, LRAM. It's called LRAM, left rectangle approximation method. That's an example of that. Look at the top left-hand corner of each rectangle. The top left-hand corner of each rectangle. What do you notice about the top left-hand corner of each of the rectangles in the first one? Mm-hmm. Yeah, there's a point, and that point is on the, it's also on what? It's also on f of x. Yeah, it's also on f of x. You notice the top left? They're always on f of x. The rest of it, no, right? The right side, nope, right? That's left approximation method. So you draw those rectangles and then you find the area of those rectangles, right? Area is base times height, right? The left one, the right one is not, right? Is not left. You can see the top left of each rectangle doesn't touch, oops, not right there. This guy, this guy. None of these guys touch the blue function, right? What is touching the blue function? Which part of the rectangle? The middle, right? The middle, the midpoint, right? The exact middle of this side here, the middle of each, right? That's an example of MRAM, right? Middle rectangular approximation method. So the question says, which one did a better job? Which one does a better job? LRAM on the left, they're both the same function. F of x is both the same. But which one does a better job? LRAM or RRAM of approximating the area under the curve? Think about it for about 10 seconds and then we'll see what we come up with. Which one does a better job of approximating under the curve, area under the curve? Okay, so how many people say LRAM does a better job of approximating under the curve? How many people say MRAM? Yeah, I would agree. MRAM is definitely, you have less, right? We have a lot of, we have a lot of missing stuff here that we need. This is area we need to add up, right? And then we have this, which is too much. And then we don't take care of this part, there's gaps in here too, but a lot less, right? The gaps are a lot smaller. So I would agree. This one is a better approximation. Okay. All right. All right. So now we're going to do 2 on our own. Okay. So number 3, they're the same function, f of x. They don't tell us what f of x is, but they say we got to find from 0 to 8. So from 0 to 8 is our bounds. Okay. For the one on the left, we're going to use RRAM. And for the one on the right, we're going to use LRAM. We're going to break this up into 5 rectangles, 5 rectangles. So if we go from 0 to 8, actually, you know what? I'm going to change that to, I'm going to make this one a little easier since it's our first one. Change that to 4 rectangles, 4 rectangles. I'm going to change it just because this is the first one. I'm going to make it a little easier on us. So I need 4 rectangles, just like the 2 above. The 2 above each had 4 rectangles, right? I need 4 rectangles. So how wide are each rectangle going to be? What's the width of each rectangle? 2, right? 2 units, right? Okay. So RAM, we start at the right edge. So the first rectangle is going to start at 2, right? Or 0 to 2. So what I'm going to do is I'm going to go up at 2 until I reach the function. Stop right there. Make a dot. Draw my rectangle. That's the first rectangle because this is RAM. Okay. I'm going to do the same thing. I'm going to go over the next rectangle, the right side of the next rectangle, go up until I hit the function, make a dot, close off that rectangle. Going to go over 2 more to the right side, go over till I hit it right there. I hit the function there, go right over, close it off, make that rectangle right there. And then the last one goes up, closes it off right there. So my rectangles, which should be as your rectangles, are right here. Okay. So let's do the same for the next one. The next one, we're going to use LRAM, though. We're going to use LRAM. So left approximation method. So that means we're going to start on the left side of the rectangle, the left side. So this is the left side. I go up until I hit the function, make a dot, come over 2 units because it's going to be 2 units wide. Okay, go up on the left side, go up until I hit the function, make a dot, come over, go up until I hit the function, 2 units. I always go over 2 units because each one has to be 2 units wide. Done. So this guy here, that's the illustration of it. The only other thing that we haven't done is actually finding the area of each of those rectangles. Adding them all up, that's our approximation. Okay, that's what we're going to do for example number 4. Okay, example number 4 is that same thing. Okay, we're going to do 1 LRAM, 1 RAM, and 1 MRAM. Okay, so here we go. This one is only from 1 to 3. So the bounds are from 1 to 3. Okay. So the first one is LRAM. So let's draw the rectangles. Let's draw the rectangles for LRAM. Oops, wait. Sorry, before we draw the rectangles, we got to figure out how many rectangles we need. They'll always tell you how many subintervals you'll need or how many rectangles you'll need. This guy right here says I need 4 rectangles. 4 rectangles. So how wide is each rectangle going to be? What's the width of each rectangle if I need 4? Even less than that. Because if I have 1 unit, I'm only going to be able to fit 2, right? It's going to be 1/2, yeah, 1/2. So 1/2. So the first one is right there. The second one It's right there. I'm only going over half a unit. And then the last one is right there. Should probably, okay. That's LRAM. The left top corner hits the function. Everything else doesn't. Doesn't need to. Okay. Let's go to RRAM. Same thing, same bounds from 1 to 3. Okay. 1/2 width, except now we're starting on the right side. So we're starting on the right side and right there. Come over, close that off. Go up. Close that off. Go up. Close that off, and then the last one's already drawn for me. Close that off. Okay. The last one is MRAM. MRAM is the middle, so not the corners. The corners aren't going to touch the function. The middle is going to touch the function. So if I have a rectangle, so I'm going to write the bounds of the rectangle. This one's a little more tricky to draw, right? So here's the width of the first rectangle here. So when I draw my rectangle, I'm not going to meet here, and I'm not going to meet here. What I am going to meet is right here. So I'm going to go up here, right in the middle, and make a dot. So right in the middle, which is a quarter, because each width is a half, so half of that's a quarter. That's going to be the height of my rectangle. The next one is right there. Okay. Okay. All the same function, all the same area, different methods. Okay, these are the illustrations. Okay, the last thing we got to do is figure out, okay, what is the area of each of those rectangles? Add them all up, we get our total area. Okay, add them all up, we get our total area. So let's start with left. Let's start with left. So we have 4 rectangles, right? 4 rectangles. How do I find area of a rectangle? Remind me again, how do I find area of one rectangle? Width times height, base times height, whatever you, however you know a rectangle. The bottom is the width, right? Or the base, the height, or the length goes up and down, right? Okay. So the first rectangle. So let's do that in the box. There should be a box. Your guys' box, I think, is on. You guys, you don't. I put a box on the next slide, but if the slides, if it's too hard to go back and forth, just write it right underneath it. Okay. The box, the slide on your notes didn't line up perfectly, so it's on the next page. Okay. So here we're going to figure out the area of each one and add them together. Okay. So let's start with L. This guy right here has a width of, what did we say the width was going to be for each? 1/2, so 0.5 times, what's the height of the first one? What's the height of the LRAM? 1 unit, right? 1 unit. Okay, first one done. Second one. Again, has a width of a half. What's the height? 1 point something, right? 1 point something. That's an issue. How do we figure out what that is? Is it 1.2, 1.25, 1.3, 1.4, 1.1? How do we figure out what that is? It might be 1.157. We don't know. How do we get a better idea of the height of this one right here, of this rectangle? What can we do to get a better idea of that? That's approximating it. I don't want to approximate it. I'm already approximating enough. There's a way I can figure out where it actually is. Plug it into. Yeah, we have the equation, right? We have the equation of the blue curve? They give it to us this time. They haven't in the past. Every other question before, they never gave it to us. But this time they did give it to us, right? So what I want to find is where that dot is, right? I want to find what that y value is right here. I know the x value is 1 and 1/2, right? I know it's 1.5 comma something. But I actually want to figure out what the y is. So plug in the x. Plug in your x and you'll figure out what the y is. Right? So this dot over here was, what was it? 1, 1. I want to figure out what this dot is here. It's 1.5 something. So right underneath, let's figure out what it is. So when I plug in 1.5 for x, what do I get for y? Okay, 1.5 squared. Well, 15 squared is 225. So if you move the decimal over twice, it's 2.25. Okay, 2 times 1.5, that's 3, plus 2. Let's see, you're gonna get negative 0.75, 1 point what? 25. Okay, so that's gonna be the height over here. Okay, the next dot. The next dot is 0.5 again. This one looks like 2 right on the dot. Now, if we weren't sure, we could do the same steps we did. You can always use that as a backup. Okay, but this one's pretty solid right on 2. So the height is 2. Okay. The last one, the last one. The last one looks like it's the same height, or it looks like it's 3.25, right? It looks like 3.25. I don't want to estimate it since I have a way of figuring out what it actually is. I want to actually figure out what it is. I want to verify that it's 3.25 and not 3.3 or 3.2 or 3.24, right? Pretty confident it's 3.25, but I have the tools to back it up. Okay, so I'm going to do the same thing. Okay. But instead of 1.5 like last time, what am I going to plug in now? What am I going to plug in to find that height? not too close. 2.5. Yeah, right here. 2.5 because that's where it starts. Starts at 2.5. So this dot right here is 2.5 comma something. We want to figure out what it is. We think it's 3.25, but I want to verify before I move on. Okay, 2.5. 2.5, so 25 squared is 625. So you move the decimal over 2 spots and you get 6.25. 2 times 2.5 is 5. 6.25 minus 5 is 1.25 plus 2 is 3.25. So, yep. So let's go put it back over here. Okay. We got all the widths. Now we just got to add them up. So this guy is going to be 0.5. This guy is going to be, what's half of 1.25? Let's see. That's 1. What's half of that? 0.7 something, or 0.8. There's a calculator. 0.5 times 1.25, and I get 0.625. 0.5 times 3.25 is 1.625. Add those all up. And I get 3.75. 3.75 units squared. Okay. So now what I want you to do is do RAM. We'll do MRAM together, but I want you to do RAM. Okay, I'll give you about 5-7 minutes to do RAM, and we'll do MRAM together. Okay. For RAM, we're focused on the top right points, right? Top right points of each rectangle. Okay. Those, some of those are familiar, right? Like I was going to crunch some numbers, but then I realized we already crunched some of them, right? Like the first one, the first height here, I'm like, I was about to crunch that number there, but I'm like, whoa, whoa, whoa. Isn't that 1.5 here? I just did that right here. So the height's going to be the same, right? Same thing over here at 2.5. I'm like, I think that's 6.25 or 3.25, but I'm not sure. But I'm like, I already did it over here. So the math was already done for me there. So what I got was this. Okay, I got 7.7, 5.75. 5.75 total area of all of them. So one of them is bigger than the other. Which one is a better estimate? Which one of left or right is a better estimate for area under the curve? Or are they both about the same? That's just the shuttle bell. What do you notice about left in area under the curve? Is it going to be an overestimate or underestimate for left? If you're estimating area under the curve, it's an underestimate. Yeah, there's a lot of, it doesn't go over the blue line. The rectangles don't go over the blue line, and there's a lot of missing, right? Let's shift over to right. What do you notice about right? It's an overestimate, right? That happens. Sometimes I'll ask you, is it an overestimate or an underestimate? That's how you tell, okay? So we only looked at this guy from 1 to 3, right? It's an increasing function from 1 to 3, right? We're not actually not going to have time to go over the last one. We'll do the last one tomorrow, or MRAM tomorrow. But one more thing, increasing, right? So if it's increasing, R is going to be a overestimate. R is going to be an overestimate. If the function is increasing, L is going to be an underestimate. Because it'll ask you, is it overestimate or underestimate? Why is it? Well, because if it's increasing, L is going to be an under. R is going to be an over. Tomorrow we'll find out what M is. Is M a better estimate? Is it a worse estimate? What will it be? Okay. So it looks like if it's increasing, one more time. If it's increasing, if the function is increasing from the bounds, LRAM is going to be an underestimate, RRAM is going to be an overestimate. Okay. All right, so tomorrow what we'll do is we'll finish off MRAM, and then we're going to go over some other ones. We're going to be doing the same thing, but now they're not going to give you a picture. They're going to give you a table on the other hand. And then eventually they won't give you either, but they will give you a function. Okay, so that's what we're going to figure. So we're doing the same thing, but just different versions of it. Okay. All right. Remember, there's an assignment due today, the assignment from yesterday. Okay, so if you haven't finished that, make sure by the end of today you scan and upload that work into Google Classroom. That's the only assignment that's out there right now.